Buongiorno. I would like to tell you a few words about one of the four research and development projects which are currently funding in Poland under the framework of so-called structural funds. So this is the stream which in our country is also used for supporting of the research development projects and not only for the projects which support the research infrastructure. Professor Okluszek presented one of them, and our project is focused on the packaging materials which are basically prepared from the compostable polymers. So in the, let's say, map of the possible application of that kind of polymers, the packages is one of the most difficult area because of two reasons. The industry needs the cheap material and the relatively big quantity of that kind of material. So this is why when we are even applied them for the particular packages, the problem starts not only the scientific problem, but also the social problem, because we should be prepared to function in the chain, starting from the producer of that kind of materials, and finally with the composting facilities which are offered by the municipalities. Generally, the aim of our projects is just to prepare the various industrial partners which are located in Poland and which are focused on the processing of classical polymers, how to deal with the polymers which are compostable. Therefore, this is the main strategic goal of the project, is to introduce the way how to adapt the infrastructure which already exists in our country in that particular purposes. We are particularly focused on the rigid packages, so this is the main goal. Of course, it is achieved by two ways. The first one is focus on the processing, and the second one on the material, which are the subject of that processing. Those are commercially available materials like lactic acid and polyhydroxyalkanoids, which are, however, to some extent modified according to the knowledge which is speciality of the partners of the project. So the project is coordinated by the Center of Polymer and Materials of the Polish Academy of Science in Zabrze, and I am responsible personally of that project. And I have a pleasure to work with the so-called main partners and the regular partners of that project. We have divided our partners because of the organization reasons of that project, because some of them are also participate with the improvement of the infrastructure. So the partners of the projects are the group of Professor Floriańczyk from the Technical University of Warsaw, and the group of Professor Marian Żenkiewicz from the Institute of Engineering and Polymer Materials and Dyes in Toruń as co-partners of the project, which are supported by the group of Professor Andrzej Gałęski from the Center of Molecular and Macromolecular Studies in Łódź, a group of Professor Hanna Żakowska from the Polish Packing Research and Development Center, and a group of Professor Marek from the Technical University of Wrocław. The structure of the project is a little bit similar to the structure of the classical, let's say, European project. So beside of this organization of, let's say, connected with partners and the ministries and the other bodies which are responsible for the implementation of such kind of the projects, we have also the scientific and technological advisory committee, which is led by Professor Ann-Kristin Albertsson from the Royal Technical University in Stockholm, and the remaining members of that body are here on the audience. The project is divided on 9 work packages. The 8 of them are connected with the research and development. However, the last one is connected with bureaucracy. It means the management and reporting, which in this kind of structural fund projects is much more advanced than in the classical, let's say, even 7 framework program projects. Because of the implementation of the research in this project, we have also had the opportunity to improve our laboratories. Here are some examples of the new equipment focused on the mass spectrometry, processing, thermogravimetrical analysis, and also the composting under the laboratory conditions using the oxomass evaluation device. However, the most important part of the first 2 years of the implementation of that project was focused on the just making the extrusion line on the pre-industrial scale, which was happened at the Institute in Torrent, and it was how it was designed, and it is how it looks like now. So this is the part where the rigid films are made currently from the polylactide, and this is the thermoforming part, which enable us to fulfill the requirements of the first planned part of the project. I mean, to establish the lines specifically connected to the processing of polylactide to the rigid packages. The second part of research which is currently going on, this is the one which we are particularly responsible on. It calls the new ways to the materials which are be useful for that kind of applications. So let me come back to the nice presentation of Professor Gerhard Barnek of today, focus about the development of polyhydroxyalkanoates in Europe. So as you see now, there are 2 companies in the United States and China which offer that material with relatively low prices, and the European industry still keep fingers crossed and hope that sooner or later we will be on the board. Martin will tell after the lunch break a little bit about the current development in this area under the Animpol project, where we are also participating. However, that situation gives us also the opportunity to look on the polyhydroxyalkanoates from the second way, I mean from the synthesis from the appropriate monomers. And this alternative way, using the anionic ring opening polymerization of lactons, it is the way which is currently also used by other laboratories, especially under development of very easy way of the synthesis of the lactons by the simple carbonylation of the respective oxyranes, which was developed several years ago in various laboratories, and it gives the opportunity to use the, let's say, carbon monoxide from the synthetic gas produced both from black coal, for example, of biomass to that kind of monomers. Using the anionic ring opening polymerization of that monomer, we can obtain the polymers with the special control of the stereoselectivity of that process, and which can be scaled up due to relatively stable end groups. Moreover, the new opportunities for the new monomers give us to tune the properties of that kinds of synthetic analogs of polyhydroxyalkanoates, particularly for the purposes we need. Here's some example of the homopolymerization and the recent example of the work of Professor Adamus on the copolymers of block kind or the statistical one. So playing with that, this is really the opportunity to go to the polyhydroxyalkanoates on the classical, let's say, chemical synthesis. However, the stability of the carboxylic sensors enable us to increase also the production scale. In our laboratory, it is on the kilogram level now, and to get the polymer with the relatively good molecular weight and the control tacticity. So for our purposes, we are synthesizing the amorphous polymer, which can be used as a partner of blends with, for example, polylactide to get the materials which are produced using that equipment which is presented by me a few minutes ago, and finally to come to the product which is the one of the achievement of the currently going Margen project. So another very important issue which is connected with the implementation of our project concerns composting and industrial composting in particular. This is the presentation given from the group of Belgium, of Bruno de Ville, who perfectly just summarized what is the advantage of the compostable packing materials beside of the classical one. However, the word of composting you can find in the scientific literature, well, to some kind of scientific literature in Poland from the 16th century. This is the book of Anselm Gostowski about the farmstead, where advisory of composting was presented. This is on the left side of that presentation. On the right side, you can see the American composting facilities, which you can just put in your house, and you can make the composting by yourself. So these are the let's say, the limitation. However, the most important is to have the opportunity to verify composting at the final place. And what we are doing now in Zabrze is a little bit connected with the example given by the Castle project, which you know probably. And it is the opportunity to have the selective separation of organic waste and their composting at the real industrial composting conditions, where we also take our research evaluating the parameters, the rate of the degradation of the materials which are developed under our project, as well as to study the phytotoxicity of the produced compost. This is the photograph of my co-workers working in this project in Zabrze. Some of them are here on the audience. I promise the honorable chair lady to finish as fast as possible, so I'll try doing that with my favorite slide with my neighbor from the country house, just saying that perhaps the future is really for biodegradable. But unfortunately, this Easter, when I visited my house, I was shocked that this neighbor prefers still polyethylene with the photograph of the smile of the tiger. So with that, I would like to finish saying that still there is a lot of work ahead of us.
Thank you. Thank you. Are there any questions from the audience for this presentation? Please.
I'm just curious, what is the purpose of blending PLA with PHP? Do you have anything in mind, including something?
Well, from the basic research studies, it depends on several factors. First of all, there's the factor concerning the rate of the hydrolytical degradation, which sometimes is too fast, and using that kind of blending, you can control it for the particular purposes. This is the one. The second thing concerns the structure of the blends, but this is the responsibility of our honorable chair lady.
Okay.